Hello everyone, welcome back to day 2 of TestMu Conference 2026. I'm Naima, Product Marketing Manager at TestMu AI, and I'll be your host for this session. And our topic will be Scaling Trust, Not Automation, Rethinking the Quality for the AI Era. Before we get started, just a quick note. If there's a point from the session that really stands out to you, share your takeaways on LinkedIn or X and tag TestMu AI, use our hashtag TestMuConf. Now, coming to our session, joining us today is Walter Zimerman, Senior Software Development Engineer at Amazon. Walter brings over 20 years of experience across quality engineering and test architecture, and he's worked on large scale systems where correctness, reliability, and user trust really matters. And that's what makes this topic really interesting. With traditional automation, when something breaks, we usually know about it. Test fails, there is a clear signal that something went wrong. But with AI, it can be different. AI systems can give you answers that sound completely correct, even when the answer is wrong. And there's where the idea of the trust becomes important. That's what Walter will be getting into today, and I'm really looking forward to this conversation. Walter, over to you.
Hey folks, good morning, good afternoon, good evening, wherever you are. Before I actually start, quick disclaimer, what you are going to hear today is doesn't represent my current employer or previous employer's positions, okay? It's all my own opinions. Something else, before I actually dive into the topic, I want to tell you a little bit story on how I got into this because I think it's related to the problem we are going to try to solve together. I am Walter Zimerman. I'm originally from Argentina, but my last name is actually of German origin. And believe it or not, that is what got me into Amazon. And it might be the reason I'm talking to you today. Back then, I think this was 2019 or 2018, late 2018. I was living in Ireland and I was sitting on site, right? This was the fifth interview of the round, so essentially the last interview of the Amazon Loop back in those days, and I already done 2 phone screens before that. And the hiring manager mentioned something on the lines of, your German speaking skills are going to be really helpful. Small problem. I did not speak and I do not speak a single German word, which I told him immediately. I got lucky. The Alexa Spanish launch was somewhere down the roadmap, and I'm a native Spanish speaker, and fair enough, this is not Spain Spanish, but close enough to get started. Thanks to that, I have spent the last 8 years of my life working on Alexa quality. First as a quality engineer, I was actually the first person that was able to hear Alexa speak Spanish end to end on a device, and then building tools to help others test Alexa. For me, and I would like to think for Amazon and Alexa too, this was the right outcome. But it was the right outcome for entirely the wrong reason when you think about it. Someone looked at my last name, they made a confident bet. They were wrong, and they got lucky. And it took me 8 years and starting to write this talk to realize that this is somehow related to the problem I'm chasing today, and I suspect a lot of you are. You see, confidence is not correctness. And let me show you what I mean with a story that is not mine. Let's see if I can make this work. This video that you are going to see now is from 2016.
Alexa, play Digger Digger.
I can't find the song to Good to Her.
Alexa,
play Street Talk.
Let him do it.
Alexa, play Digger Digger. Alexa, play Digger Digger.
Oh. Bobby, can you tell it to play Wheels?
You want to hear a station for porn detected. Porno ringtone, hot chick, amateur girl, calling
No,
sexy.
No.
Pussy anal dildo ringtone.
Alexa, stop! Right. What you just saw kicked off an internal effort that produced something that the team called Earcons. You know that annoying little deflection that Alexa used to make when it decides not to engage? It actually exists because of moments like the one on the video. Here's how it works, or it used to work very roughly. Most natural language classifiers give you a confidence score between 0 and 1. After this incident, the team added a safety mechanism. When Alexa's confidence in what it heard from the user was below a certain threshold, it would actually deflect instead of acting. It would make the Earcon and then stay quiet. And when you think about it, this is a reasonable engineering response. It's also a moment that is pretty important and I want to hold in your head because something very subtle happens. The system stops failing loudly and suddenly it starts failing politely. But the error itself did not go away, it just gets quieter. And yet, even with those safeguards, this still happened in 2021. Essentially, a kid asked Alexa for a challenge, and Alexa decided to tell the kid to put a penny into a power outlet and then touch it, right? The kid was smart enough to tell her mom, and she is safe. I want you to understand that I'm not telling you this to pick on Alexa, right? I worked on Alexa, and I really love Alexa, right? It's part of what I've been doing for the last 10 years of my life almost. I'm telling you this because Alexa is one of the oldest, most heavily tested voice assistants in the market. And these things still happen or were able to happen in 2021. And if it can happen there, sorry about that, if it can happen there, it can happen anywhere where we are putting probabilistic systems in front of our users. Let me tell you a little bit about myself and how and my relationship with LLMs and generative AI. I started experimenting with LLMs in late 2020, right? This was GPT-2 time. And then in late 2021, I demoed some of this work to leaders at Amazon at an internal summit. I showed test case generation, some early experiment using language models for classification and assertions. For you to understand and for context, ChatGPT came out in November 2022, and the term LLM as a judge was popularized in June 23 with the Zeng paper on empty bench, right? By December 2022, the automation framework that I've been prototyping and working on since 2018 already had synthetic customers, simulators, and the first set of LLM powers judges. Now, I'm not telling you this to brag, okay? I'm telling you this because I think I got lucky. When I started experimenting with these tools, they were bad, really bad. And it's easy to forget now that we have the Claude family of models and the latest GPT families and everything that came after, how rough the early models were. And because they were bad, I never had an option to trust them. You see, I had to question every result, which led me to one question that I could not put down. How do we know we can trust them? How do we know these systems are adding value? And in particular, how do we know we can trust them when we're using them to evaluate the quality of another system so that we can make decisions on whether to ship or not? I was pretty sure, even back then, that LLM-powered assistants were going to show up everywhere and fast. We were not really using the word agent yet, although it already existed, but the overall shape was there. So the question was definitely not going to stay academic for too long. But before I talk about trust at scale, I want to make sure we are talking about the same thing when we say trust and when we say scale. Bear with me, I'm kind of a little bit of a lexicon nerd. Okay, scale, in computer science sense, it's the system's ability to handle growing workloads without losing performance. Here's a fun fact. The word actually has two roots, the Nordic skal, meaning bowl, right? And the Latin word scala, which means stairs. I will actually let you decide which one applies to your own pipeline, okay? And trust is a firm belief in the reliability of someone or something. Firm belief in the reliability of someone or something. And belief, if you keep pulling on it, is actually faith or confidence, right? Reliability is the degree to which something can be depended on to be accurate. So if we put all this together, scaling trust is actually the ability of a system to sustain grow in a reliable way, right? And to be able to sustain a reliable belief in its accuracy and dependability as the demands increase, right? So without that belief degrading under the weight of their growth. The piece that I want you to take from this is that trust has to be earned, right? And it has to be measurable and it has to compound. If reliability itself falls, then trust won't scale, right? Which means we have to treat trust essentially as a dynamic property of the system from day one. It's not a label that we can put after the fact. That's actually really hard. And that brings me to the overall idea of these talks. You see, the reason scaling trust is hard right now, and the reason that is genuinely differently from what we were doing 5 years ago, comes down to one sentence. Traditional tests fail loudly. AI fails confidently, right? That would be the thing that I would like you to take from this talk. From now on, I'll try to just convince you that this is true. And then discuss what we can do about it if there's anything. So let's start discussing why this is hard. And I want to walk you through 3 things. First, what actually has changed about how system fails. Second, why the math is actually more unforgiving than most people think. And third, I want to believe what I believe we can do starting next week on this, right? I want to start with what has not changed because I keep hearing the opposite. I'm calling these actually, these times, I'm calling them the rise of the applied scientist. The role, the practices, the jargon, all of it is creeping into our industry. I find myself using words like precision, recall, F1, specificity in conversations where 5 years ago I would have just said pass and fail, right? And I see test catalogs becoming data sets. I actually like that one, I think. And test suites becoming test sets. And I have started hearing from smart engineers, really smart engineers, that this overall idea that traditional testing does not serve a purpose anymore because models do not have binary outputs. I had a conversation with actually a junior engineer that is really smart. And there was a really strong discussion 2 weeks ago. And I want to push back on this very, very hardly. You see, here's the truth. The application under test still has a job to do, right? The user doesn't care how it works. They need it to book. You see, if they need to book a flight, right? Or I need to book a flight using an assistant, I want the reservation to be real. If I purchase something, I want the right amount to be charged and the right product to arrive on time. If I'm working with a voice assistant and I set an alarm, I need that alarm to ring. And say that someone sends me a calendar invite, I want my device to reflect it properly. So you see, functional and quality attributes testing matters as much today as they did 5 years ago. The goal of testing has not changed. What has changed is that now we have some stochastic components inside the system, and we need to verification methods essentially for those components. And that is a much more precise statement than saying that testing is dead. And it leads us somewhere useful instead of nowhere. And the first place where the tool actually misleads us is volume. When I joined Alexa in 2018, my team was responsible for testing the international expansions. My manager, the same one who thought I spoke German in the interview, wanted us to build an automation suite that would run continuously across every locale we supported. There was no tooling on the market, so we built our own. There was almost no literature on how to test a system like Alexa, and honestly, there's still not. Right? We had a lot of arguments back then about what it would take for that initiative to actually add value, and I kept worrying about one thing: how are we going to review the results? Imagine the same problem today, right? With generative AI on your side, everyone is producing thousands of test cases before launch. It sounds amazing until 5% of them fail, and you're staring at what, 3,000 failures, 4,000, 5,000 failures, and you have no idea which ones are real, which ones are hallucinated, or how to prioritize them. You see, more tests do not mean better understanding. More tests do not mean more coverage. More tests do not mean fewer bugs. More tests do not mean a more stable product. More tests do not mean happier customers, right? Volume has always been a vanity metric, right? It measures effort. It doesn't measure value. And that is the basic principle. And you know, there's this basic principle essentially that exhaustive testing is impossible. And this is still true. It's just that now we can fail at exhaustive testing much faster and much more expensively because every one of those tests has some form of token cost attached to it, right? Volume without interpretability is just noise. But now we have a confidence score attached to it. Which brings me to the distinction I think a lot of teams are still working through: testing versus evals. Testing asks, did it pass? Evals ask, how good is it and how do we know? Traditional QA used to give you green or red, while evals actually give you a distribution. And most teams are not ready for that conversation yet. I want to be really careful here, okay? I'm not saying evals replace testing. I am saying there are different tools for different jobs, and combining them carelessly is where I see the teams get into trouble. Test executions can produce data that is great for evals, okay? And eval results can tell you what to test next and when. Those are healthy connections. What I push back is on this idea that one subsumes the other, right? When a platform tells me that an item has been added into the shopping list, I still need to validate that the item is actually on the list and that it shows up correctly. That is testing, okay? When the response, whether the response or if the response that Alexa gave me is culturally appropriate for the locale, or if the accent is right and the pronunciation is correct, that is an evaluation. Both matter. They answer different questions. And here's where the tension essentially shows up, you see, because in the end, your pipeline wants a yes or a no. Your release gates want a yes or a no, and your stakeholders want a yes or a no. We are building systems whose outputs are probabilistic, and then we are handing them to consumers who needs determinism. Even when we set acceptable thresholds and call it a day, we are ultimately reducing a distribution to a binary at some point in the pipeline, right? That reduction is where trust essentially will start quietly breaking, because percentages are really hard to reason about. What if the 1% that fails is the most critical path on your system? What if a scenario fails 0.1% of the times, but that feature is used millions of times a day? That's essentially not an edge case, right? That is a headline similar to the one I showed you waiting to happen. And this is where I want to come back to the overall idea that I mentioned earlier, because everything downstreams to it. You see, a traditional test that fails essentially will throw an exception. Your pipeline will stop, you go, you take a look at it, and if you have decent traceability, by the way, you can try to find my Starist talk that I gave this year on how to build a system that allows you to do that. If you have good traceability, you can usually figure out what went wrong fairly quickly. An LLM does not fail like that, right? An LLM gives you a beautiful, very confident, and completely wrong answer, right? There is no exception, there is no red light, there's just a sentence that sounds and looks amazing. I want to share something a little bit uncomfortable. Recently, I demoed some form of proof, like it was really a proof of concept, right, on a new testing approach. And I have been working on that for a while. I validated the results with the QA engineers who run the same test manually, essentially, on existing infrastructure. And then the issues that my solution found were real, and it was useful. There was value in the approach, but the solution is using agents in several places. I guess like everyone is kind of going in those directions and exploring. But you see, I am not confident that this is reliable enough to put in production and to deprecate the old system, or even to replace it, or even where to go. To my concern, and here's the problem, some stakeholders had, hey, the proof of concept found real bugs, and translated it into, we should productionalize this today. And I had to be the person saying no, because finding real bugs in a demo is not the same thing as being trustworthy in production. You see, the gap is exactly what I'm trying to talk about, and this is what I'm living right now. So, failure looks different. There's a problem with probabilities and trust, but you see, let's see why the math make this works. I want to do some very basic arithmetic with you, bear with me, right? This will be pretty straightforward. Let's suppose that you have a component or an agent that is accurate 95% of the time. Whatever accuracy means for your system. That is, trust me, a pretty good number. Most teams are going to be super happy with 95%. Now, suppose that you add a second component that is also 95% accurate. Do you think you can tell me what is, or think about what is the overall accuracy of them together? Instinctively, some of you might have said 95%, right? You have one system 95% and the other one is 95%, but the reality assuming that all the components are independent, is that the pipeline accuracy is ultimately the product of the individual accuracies. Let's take a look, right? By the time you have 5 components, you are at 77% accuracy. And by the time you have 10, you are below 60%. And every one of those components has individually a 95% accuracy, right? And you are super proud to ship each one of them. The natural question here is going to be, what if we ship fewer components? Or, like build one big agent that does everything? And the short answer is no, we cannot do that. Not with the current state of the art. You see, even if models are getting smarter and the context windows are getting bigger, and yet with all these things, the research keeps showing that agents trying to do too much ultimately degrade. There is a phenomenon called context rot that is pretty interesting. There's good empirical work on it. You can search for it and try to find it. And then on top of that, observing and debugging a single agent that does everything is, in my experience, much harder than debugging a pipeline of focused components. So after this, we're stuck with the math, which means we cannot hand wave trust at a system level. We have to earn it at the seam between every component. What can we do? And I'm not going to pretend that I have an answer to this. As an industry, I think we're still learning. But there are a few things that I believe today I think can get us closer to this. Oh, and trust me on this, if someone tells you that here's exactly what you need to do, they are most probably trying to sell you something of some sort. The first thing sounds very obvious, and yet is not. Measure from the start. It is very easy to build a quick prototype. Engineers, and myself included, we have a tendency to be solution-oriented before we are problem-oriented. There is data going around that shows that 95% of the AI startups essentially fail or are failing, and the 5% that succeeds are the ones solving real problems for real customers. And I truly believe that the lesson generalizes, right? You need to know the problem before you build a system, and you need to know what success looks like before you can claim you have achieved it, which ultimately for us in these stochastic systems means data sets, ground truth, even a small, scrappy version of it, because without that baseline, you cannot tell whether your system is improving, degrading, or just changing. You cannot retrofit this. It's very hard. So how do we do it, and what do we do there? Well, I'm a big fan of test-driven development myself. I still do it today, even when AI writes, I would say 95% of my code. The analog to the world we are now living in is what I called evaluation-driven design, right? Or I've actually heard the term, it's not my term, but it's a really good one, evaluation-driven design. The loop looks essentially like this. Before you build the agent or the component, you write examples of what good looks like for that agent. Inputs, expected outputs, expected properties of the outputs, and you treat this eval, because that's what ultimately it is, as a test. You treat it as a test, right? You build some form of harness and you run it. And it should fail because there's no behavior yet, right? That prevents you from writing trivial evals that always pass, or trivial eval-based test cases that always pass. Yeah, something along those lines. Then you build the smallest thing that makes the test pass, or that eval pass. So usually this is going to be a very simple problem that it can be even hard-coded, right? But you go to green with this. It shows you that your wiring is in place. It shows you that you are calling the right pieces of your infrastructure, and then you refactor, right? What does refactoring means here in the time of agents? Cheaper model, tighter prompt, fewer tools, and you will run your evals. That eval ultimately becomes your safety net, right? And you commit it alongside the component. The same shape as TDD, exactly. The crucial difference is that green is somehow going to be probabilistic as it moves forward, right? It's just not deterministic. You are not asserting equality, you are asserting that a distribution over outcomes meets the threshold for that agent, which means every refactor has to account for some small form of variance, not just correctness. And once you have more than one component, you need a second loop around the first one. Some of you who have lived through the microservices era will recognize this shape. This is ultimately the double loop TDD, but adapted, right? The inner loop is component level, it's fast, it's focused on the contract of each of the components, while the outer loop is system level. It's slower, it's more expensive, it definitely runs less often, and only when you have a reason to run it, not 24/7. Its job is to catch the cases where every component passes its own evals and the system still produces garbage, or cost too much, or loops forever, right? The two loops talk to each other. When the outer loop catches something, you diagnose which sim broke, and then you write a new inner loop that would have caught it, right? The outer loop failures become the inner loop test. You see, exactly the same way production bugs become unit tests in a mature code base, right? Over time, that inner loop gets denser, and the outer loop will start catching fewer surprises. That is, I believe, what maturity looks like for this kind of systems. I will be honest. I do not have the answers for some of the questions here, right? How do you version evals when the prompts underneath them change? That's a huge topic. How do you keep the outer loop affordable enough to run on every commit? I have my own thoughts, but still a lot of research to be done there. How do you write evals for emergent behaviors, right? Where the swarm, if you have a swarm of agents, goes and does something that none of the individual agents were evaluated for, right? And there's this idea that I've been toying around lately, which is emergent bugs, right? There might be bugs that don't exist in isolation, and at some point your swarm actually produced them. And if you have ideas about this, please reach out and let me know, right? I'm super happy to engage with you all on LinkedIn. The last thing I want to say before I wrap up, it's a thing I keep thinking about and keep coming to, right? I believe we have been somewhere like this before. Of course, it's not the same thing, but it is similar, right? Some of you leave the migration to microservices. I find myself more and more reaching back to what now we consider classic literature. Agile testing by Lisa Crispin and Janet Gregory, continuous delivery by Jez Humble and David Fairley in particular, among others. Because the shape of the problem is familiar. When microservices took off, right, the end-to-end test pyramid got inverted, right? And it actually hurt. Teams discovered that full system integration tests were slow, right? Let me bring it here. Yeah, so teams discovered that full system integrations were actually slow, right? They were flaky, they were expensive, and the bugs that they caught were often the wrong ones. The fix was essentially contract testing, right? Pin the interfaces between two services and test each side against the contract independently. For multi-agent systems, I think that the analog is the handoff between these components. You see, the inputs and agent specs and the output it promises. Pipeline level evals are the flaky end-to-end test cases of this era, I feel. Second one is that observability actually beats testing production, right? You could not pre-test every path to a distributed system, so the industry moved the budget from more tests to tracing. Structured logs, correlation IDs, multi-agent system need exactly the same discipline. Every prompt, every tool call, every intermediate output traced end-to-end with a shared request ID. Because when something goes wrong 3 agents deep, reading a transcript, it's ultimately you're the bugger, right? And schema versioning was non-negotiable. Learn the hard way, right? When a breaking change to one service response format took down consumers nobody remember existed, right? The agent version of this is ultimately version prompts, structure outputs with schemas, and tracking which downstream components depend on which upstream behaviors. If you change the system prompt, you have just changed the contract for every tool that the prompt touches. Treat it that way. That is the best thing to do. The meta lesson from microservices is that the QA center of gravity moved from testing the whole thing to contract the seams, right? Observe the flow, isolate the iteration, all these different things. This is almost certainly where agent QA is headed. And I want to name one more thing before I close. I kind of think it's the role shape consequence of everything I just said. What I've been describing is a job, I think, that sits between the QA engineer and the data scientist. I've been loosely calling this the QA scientist. I do not exactly what it looks like yet, not fully at least, but I really know what it needs to do. It needs to design test frameworks, and it needs to reason about statistical significance, right? It needs to think about the contracts between the components, and it needs to think about the distribution over outcomes, right? It needs to be comfortable saying, hey, this is 87% reliable, and also comfortable saying, here's why that is definitely not good enough to ship. You see, I watch QAs teach themselves statistics because the job demands it. And I watch data scientists build great models, and they don't really seem to have a great instinct on how to test them in production, right? I've sat in meetings where they were with QA departments and ML engineers, and they were basically talking past each other for an hour because they're essentially their working definition of quality are different. So I think this role exists. I think most of us have not named it yet. And I think some of the people listen today to this talk, or potentially me, are we either going to grow into this role or hire it for the first time, maybe in the next couple of months. So as a closing statement, right, I want to go back to where I started. Someone, when I think about it, looked at my last name 8 years ago, and they made a confident bet. They essentially made an inference, right? And they were wrong, but they got lucky. And it took me 8 years and writing this talk to realize that this was a problem similar to what we are doing today. You see, somewhere in your pipeline right now, you have a component that is returning the right answer, and you do not know why, right? And the question then comes, it's not about should you trust that component. The question is, how are we going to prove that we should trust that component? That's all for me now. Thank you very much for listening to this talk. As this is a recording, I'm not able to answer questions live, but following that QR code, you should be able to reach out to me on LinkedIn. I'm super happy to engage over there and answer whatever questions you might have. Thanks a lot for your time.
Okay, sorry for the delay. Thank you, Walter. It was really an interesting session on a relevant topic, I must say, and definitely one that's becoming more important, and more teams, as more teams are started working with AI-driven agentic systems. And thank you everyone for sending so many questions. But apologies, we won't be able to take them live today. But please keep them coming. We'll be picking some of them through our social media channels, our blogs, and so do keep an eye out there. And also, guys, once again, I am reminding you, do share your takeaways from this session. Keep the conversations going on LinkedIn, X, tag TestMuAI, use our hashtag TestMuConf. We would love to hear what you found most interesting about these sessions. And we have more great sessions coming up tomorrow, so stay tuned.